Good day, viewers. Today we are going to be dealing with mathematics, and the topic of study is longitude and latitude. In handling this topic, the following instructional materials will be effectively used. The first one to be used will be the diagram of the world globe obtained from the internet, showing the maps of a few continents and the lines of longitude and latitude. The second one to be used will be an improvised globe using iron to construct the longitude and the latitude as well as other sectors of a globe. And the third one to be used will be a printed material produced by the Lagos State Educational Resource Center, showing the longitude and the latitude. Physically displayed here is the printed material, the poster showing the lines of equator, latitude, and the longitude. Viewers, while wishing you an interesting learning and teaching experience, we want to invite you also to our own site where you will have enough knowledge on how to improvise and produce instructional material. The site is http://www.laserc.org. Ladies and gentlemen, thank you for listening.
Good evening, dear students.
Good evening, sir.
Well, before we start this topic, I want to ask a question. Have you heard people say that while we're in the night in Nigeria here, some people are in the day?
Yeah.
Yes, sir.
Can you tell me why that is so? Some people are in the night, and others on the same surface of the earth are in the day. Because of what?
The shape of the earth.
And different places on the earth have things that we use to identify them. When you're talking about graph, you have your x-axis and you have your y-axis. Is that right?
Yes.
The combination of the x and y-axis will enable you to determine a point. The same thing on the surface of the earth. We have a combination of two things that will help us to locate where a place is. For example, in Lagos here, we can say Lagos is on so and so. And that is going to lead us to the topic, longitude and latitude. To the topic what?
Longitude and latitude.
Before I proceed, on this topic we're going to learn some things. And some of those things we're going to learn are, as you can see, the objectives of this lesson. At the end of the lesson, you should be able to, 1, describe the shape of the earth. 2, explain briefly the rotation and revolution of the earth. I know you talk about this, you think this has to do with geography. But you will find that there are questions, even on mathematics, would involve the rotation of the earth. You say, okay, what would be the distance when the earth rotates on this, so. And that's why you need to know what is rotation before you can answer the question on rotation. I hope I'm communicating.
Yes.
Then we want to define, also you should be able to define what lines of latitude and longitude are. And of course, if I say, okay, I want to move from this place to Abuja, you have to know the distance from here to Abuja measured along the line of latitude. These are things we're going to talk about for today. Can you see how the earth looks like? You've seen an orange before?
Yes.
I know you have. The earth is like a ball, though it's not a perfect sphere. We call it, in geography you call it what? Geoid. Fine. Here we call it a spheroid. If you would see, look at this. Can you see this? This is like the Earth. Is that right?
Yes, sir.
Now, look at this 60 degrees, 45 degrees, 30, 15. The equator, 15 degrees south, 30 degrees. What do we call them? We call them lines of what? Latitude. What do we call them?
Lines of latitude.
And you can see the lines of latitude. This. If there were another one here, they are parallel. Is that right?
Yes.
That's why we call the lines of latitude parallel. We call them parallel lines of latitude or parallel. If you look at it again, you see another one that goes from the top here. We call this place the North Pole, and we call this place the South Pole. These lines, they pass through the North Pole and also the South Pole, but they go just this way and that way. Each of them passing through the North Pole and the South Pole. What do we call those lines? They are lines of longitude. Exactly. The combination of the line of latitude and the line of longitude will determine the position of a place on the Earth's surface. Just as the combination of your x value and your y value will determine the point on your graph. Do you agree with me?
Yes.
And the equator here is the biggest line of latitude, and it is from there we measure upward, and that's why you see them north, while we also measure downwards, southwards, and that's why you have degrees south there. I hope that is clear. We'll talk more about that as we proceed. You can see that. Look at the shape of the Earth. The shape of the Earth closely resembles a flattened sphere, a spheroid with an equatorial, the equator is the middle, equatorial radius of 6,378 kilometers, while the distance from the center of the spheroid to each pole, when we say each pole, the North Pole and the South Pole, is 6,357 kilometers. You see that the two of them are not the same thing. That is why we say it is not really a perfect sphere. If it were a perfect sphere, the two radii should be the same. Is that not so? Yes. But for the basis of our calculation in mathematics, we're going to assume that it is a complete sphere. I hope that is clear. And we'll take the radius as 6,378, though approximated to what? 6,400 kilometers. But you don't approximate unless you're told to do so. Now you can see these are parallels of latitude. The equator there, another parallel of latitude. This is to the north, while this is to the south. And of course, what are these? They are lines of longitude. What are they?
Lines of longitude.
I hope that is clear.
Yes.
Now, students often have problems with trying to make calculations on longitude. Look at this diagram here. We're going to also use this to explain. Can you see this line?
Yes.
This line is moving towards this point here. It is just like this line here. Okay, it's just like this line here. Okay, can you see the line?
Yes, sir.
It is just like this line. Now this is the equator. Is that right?
Yes.
Take this line I'm showing you just as this. If the angle between this and this is theta, let's call it theta. The angle between this line from the center of the Earth to that point on that line of latitude, if that angle there is theta, then it means that this line of latitude will be latitude theta degrees north. If it is alpha, it will be latitude theta degree, alpha degrees north. But if it were like this, this will not be south.
Yes.
If this angle now is say 40, then because this is the equator, this will be latitude 40 degrees south. Exactly. I hope I'm communicating.
Yes.
So when we say latitude this, longitude this, you know what we mean. So what are the lines of latitude now? The lines of latitude or parallels are imaginary parallel. Imaginary, what do you mean by imaginary? You just imagine them. It's not as if on the surface of the earth, in the sky, you will see lines. No. They just imagine it to be there. They are parallel because you can see that this and this are parallel to each other. If there's another one like this, it's parallel. Just as if you take an orange and you cut it. You can cut it on top, you can cut it in the middle. It will still give you what? A circle by the time you remove it. They are imaginary parallel horizontal. Latitude are horizontal, but longitude are what? Vertical. Longitude are what? Vertical. Exactly. Imaginary parallel horizontal circular lines. We call them lines, but we want you to know that they are circles. Because in the calculations we are going to do shortly, we are going to involve calculations, and we are going to have calculations involving circles, sectors of a circle. So you have to know that they are not really lines in the sense of lines, they are circular lines drawn around the surface of the earth. The latitude of a point or place on the earth's surface, just as we said here, is the angle between the horizontal line of the equator. Where is the horizontal line of the equator now? You can see that horizontal line here. This line here. You know it's horizontal. This we won't say horizontal, parallel to the ground. Of the equator. And the line joining the point to the center of the earth. Where is that line we're talking about now? This. The angle between the horizontal line of the equator and the line, this line, joining the point. You want to know the latitude of this point on the earth's surface. The angle between that horizontal line of the equator and this line that joins that point to the center of the earth is the latitude of this. That is, if this angle is 40, then this is latitude 40 degrees north. Is it clear?
Yes.
Join the point to the center of the earth. Can you see that from the diagram there?
Yes.
That is just on the board, but you can visualize it here, the way it is. This is the line of latitude we are talking about. This is the horizontal line of the equator, and this is a line that joins that latitude to this place. The angle between them is what? 41 degrees, and that is what makes that latitude to be 41 degrees north. I think that is clear enough. It is thus the angle between the horizontal line at that point. The horizontal line at this point, we're taking this latitude for example, the horizontal line at this point is just something like this. The angle between that horizontal, look at my palm, my hand the way it is, that horizontal level there. The angle between that horizontal line at that point and the line joining, okay, let's, between this, and the line joining this point to the center of the earth. Now, I just said this. I said now the angle between this line and this line is also the latitude. Why is this so? Look, I said, and since this angle and the first angle mentioned are alternate angles. I think you have heard of alternate angles. Alternate angles are Z angles. Is that right?
Yes.
Look at, can you see that this looks like Z?
Yes.
Whatever this angle is, that is also what this is. So if this one is theta, this is also theta. So this angle can also determine this latitude as latitude theta degrees north. I think that is clear.
Yes.
The equator is latitude 0 degrees. This one in the middle is the equator, and it is latitude 0 degrees, and it is the reference point. You know what we mean by reference point? The point from where other things are determined is the reference point. It is the reference point from which other latitudes are measured northward or southward. I think I'm communicating.
Yes.
Latitude 90 degrees south being at the south pole, that's here, the last one, while latitude 90 degrees north is at the north pole. I think that is clear there as regards the latitude.
Yes.
Then what is longitude? As I said, a combination of the latitude and the longitude will determine the position of a place. Lines of longitude or meridians. These are imaginary vertical circular lines drawn across the surface of the earth, passing through the north and the south poles of the earth, and at right angles to the parallel of latitude. Now look at this. This is a line of longitude. Is that right? This is a line of latitude, which is the equator. Can you see that? What's the angle between them? 90. What's the angle here? So the lines of longitude are at right angles to the lines of latitude. Communicating? Passing through the north and south poles of the earth and at right angles to the parallels of latitude. The longitude of a place is the angular distance of the place measured eastward or westward from the what? I want to keep you in suspense. Have you heard of what you call the Greenwich meridian? Greenwich meridian is just, for the latitude, what's the reference point for latitude? The equator. For the longitude is the reference point, and it is longitude 0 degree. It is what?
Longitude 0 degree.
If the Greenwich is like this, longitude 0, and you have another line of longitude that comes across it like this, passing through the North Pole, you can see there will be an angle between these two palms here.
Yes.
Is that right? If this is my 0, the way you are now, let's say this is longitude 0, the Greenwich meridian. Look at my palm. It is to the right of Greenwich. Is that right?
Yes.
And to the right is what? East. To the left is what? West. If the angle between the two of them here is theta, then this will be longitude theta degrees east. If we use this as our example here, let's assume this is longitude 0, the way you are looking at it. This is longitude 0, the Greenwich meridian. Look at this line of longitude. This is another line of longitude. Is that right?
Yes.
If the angle here is 40 degrees, then this is longitude 40 degrees east. If the angle here is 20 degrees, this angle is 20, then this will be longitude 20 degrees west. Clear?
Yes.
So on. So between the Greenwich meridian, which is longitude 0 degree, the Greenwich meridian passes through London in where? Britain. And it also passes through Accra. I know you have heard of Ghana.
Yes.
Yes. The Greenwich meridian passes through Accra in Ghana. All other longitudes are measured from 0 degree, can you see, to 180 degrees, both east and west of the Greenwich meridian. When you move from here, if there were if a longitude, line of longitude were here, that would be 90 degrees. I hope I'm correct. So 0, 90 degrees east, then to 180 degrees east. Again, 0, 90 degrees west to where? 180 degrees west. You will now notice that the longitude, this same line of longitude 0, is the same one at the back. Can you see?
Yes.
It's the same line at the back that has now formed what? Longitude 180 degrees east or west. The same line that is longitude 180 degrees east is the one that is longitude 180 degrees west. Am I communicating?
Yes.
All other longitudes are measured from the 0 degree to 180 degrees, both east and west of the Greenwich meridian. The line of longitude in conjunction with the line of latitude is used to determine the position of a place. Note that a line of longitude has two opposite values. One in front, while the other is at the back. If you are talking about this one also, this one in front, the other at the back. It is the same line. I think that is clear. If you were to look at it, if this angle is 30, for the same line here, this one will be what? 60. No, 90 plus 30, 120. Because it should be a straight line. Angle on a straight line is what? 180. So if this one is 30, the remaining one here will be 180 minus 30, which is what? 150. So that longitude 30 degrees east is the same line of longitude 150 degrees west. Am I communicating?
Yes.
Yes, sir.
The line of longitude that is 30 degrees in front is the one that is longitude 30 degrees east in front is the one that is longitude 150 degrees west at the back. Clear?
Yes, sir.
So while the other is at the back, each longitude 0 degree is on the same line of longitude, the same great circle as longitude 180 degrees west. Similarly, longitude 30 degrees east and longitude 150 degrees west are on the same line of longitude, one in front while the other is at the back. Longitude 90 degrees east, that's 90 degrees east. Suppose we start like this. 90 degrees east here is also the one that becomes 90 degrees west. And 90 degrees west are the same great circles. I know that will lead us to what is a great circle. Because I said great circles there. We talk about small circles and great circles. What is a small circle? If you watch this, do you notice that the radius of this is smaller than the radius of this?
Yes.
But for these longitudes, all of them